All right. Yeah. So what we want to talk about today is a problem statement related to REST API design. Yeah. We would be covering API design with respect to some of the basics of API design like URL, methods, um, then request body, response body. How do we go about designing REST APIs, right? Given a particular problem statement in mind. So instead of just covering a theory, we will try to do this with an actual example. And the example that we want to take up uh, is this OTP based auth. Imagine I'm assuming you're able to still see the full screen where you can see the title of the screen, right?
Yes.
So yeah, so the problem statement is pretty simple. We these days imagine that we have typically web applications or websites, right, which allow you, which ask you to actually sign up via your email username password, and they also ask you your mobile number typically, and then once you log in, there is a mobile. Once you sign up and log in, there is a mobile based second factor authentication where even after you send your username password, there is a typically an SMS or a authenticator. You can use authenticator app, one of these two parameters, and second factor authentication is being used for authorization and authentication, right? So this is the problem statement that we want to build uh, an API that can be consumed or used by any other application where there is a OTP based authentication, right? So this is the detail of the problem statement. We want to design the auth flow APIs that should include a sign up, login, etc., right, for a OTP based user authentication. So that means user will sign up with an email, password, and mobile number. They will then log in with a username and password. Once they log in, they will be presented with an OTP on the mobile number, and then they are supposed to enter that OTP, and we'll on the backend we'll validate whether the OTP is correct or not. And if the OTP is correct, we allow them to browse to the website, etc. Right, so imagine we want to build something like this. How would we go about designing REST API and the backend for this kind of application? So again, you might have a question as to, this sounds like more generic. So is there anything specific that we want to build? So you can plug it into any of the standard like APIs, or I mean any of the backend applications. So for example, we can consider, so this is Akshay's dog. Her name is Silky. So imagine we are building a silkystore.in website like that, where you can browse pet products. Yeah, and you can buy pet products. So you can buy products for dogs, cats, and whatnot. Right? That's the store that we want to build. It will be an e-commerce kind of web application. We will also think about maybe building a mobile app and a web app and stuff like that, right? So imagine that is something that we want to build. So how this will be done is typically for any e-commerce these days, there is a clear focus of web plus mobile plus backend, right? So typically the web UI is written in some UI framework like React, Angular, or what have you, right? Almost like a single page application framework, any other single page application framework. Then there is typically a mobile app, which again can be written in React Native or Android or iOS specific platforms and whatnot. And then ultimately what powers them is the backend API. You need database to store some state. You have to host it on some cloud and manage and deploy and monitor and whatnot, right? So we'll not cover all of these parts, but that's the overall web REST web architecture that is typically followed for most websites and web applications. Right. So the structure that we want to build and why we want to build APIs is that look, we could actually build a website to start with, right? By website I mean you could just do a web app without the proper REST API. You could do it via a server rendered application using something like Ruby on Rails, Django, or any other framework on any other languages. Where the APIs are not really stateless, they're not REST APIs. But the reason to build and the main use case for REST APIs is that you don't want to be storing and managing state on the web app itself. What that means is you want the APIs to be stateless, so that you can scale them independently, and then they can and will be potentially used for any other third party, any other clients going forward tomorrow, right? For example, you may start with web application to start with, but you definitely have plans. If things go well, then you definitely have plans to build separate specific mobile apps, right? And in that case, if you build apps using stateful APIs, not the REST APIs, then it causes problem where you have to rewrite the entire like backend to remove the state from the backend, right, and push the state to the user. So this is the use case primarily why we want to build REST APIs. So what is the user flow going to be, right? So by user flow, I mean, okay, how are users going to use this API? Imagine all of this is built. What is the use case like? How are people going to use our website, right? So typical flow is going to be that they sign up on Silky Store using email, password, and mobile number, something like that, right? Then there is they log in using their email and password. Once they log in, we will send them an OTP on their phone number that is registered. Then they enter the OTP and we validate the OTP. If it's all good, then we allow them to order stuff from Silky Store. We then have the whole e-commerce application, payments, and whatnot. What we will focus on today is just the user flow or the API part of it. We won't look at the actual e-commerce bit and how it will be implemented. We will primarily talk more on just the REST API part. All right. So before we go on some of the happy path and how each of the APIs are, let's actually talk about some unhappy paths that we may have to think about in real world, but we will mostly be ignoring for this discussion. Right? So one unhappy path is invalid details. Like how do you validate email? How do you validate phone number? These could be basic validations we could put in place, but things like, does the phone number belong to the user, or how do we really know whether this phone number is valid or correct and reachable and whatnot? We will ignore this. What if user already tries to sign up using an already existing email, right? Like I want to sign up with someone else's email, for example, or someone else's phone number, right? Then signing up with some other user phone number. Yeah, we spoke about that. What if whoever is trying to log in, they try guessing the username and password by just a lot of combinations, right? Because these are going to be public APIs. So we will have to worry about some of these conditions. So we may need to have some sort of rate limiting or some sort of mechanism to allow only few invalid attempts. And after that, those many attempts, typically you may want to block the user, you may want to block IP address, you may want to do some action based on that. What if the user, everything is good, but they just don't get the OTP because the SMS sending provider that we're using is down, or there's some issues, or there's just some latency. So what happens in that case? Like how often can users request OTP, right? If they enter the wrong OTP multiple times, how many wrong attempts do we want to allow? It is kind of similar to the invalid login attempts, right? And bunch of more. For example, there could be brute force attack on the username password combination, some public APIs. There could be DDoS, there could be cross-site scripting. There is for a public REST API, there is a bunch of things that one has to worry about. We'll not worry about some or almost most of these in this session for now, right? So what will we worry about, or what will we build then? So we said that the user flow is sign up, login, and validate OTP overall, right? So these are based on that user flow, these are some of the APIs that we will need to build. One is the sign up API itself, right? Where user can sign up using email, password, phone number. Then they need to have some login API where they can, again, once they sign up, they get some success response. If that's success, then that hopefully means we have saved their data in database and now they can log in. So for login, we'll ask them their email and password again. Now here is some things that we could do as part of backend implementation. We could send the OTP as part of login response. By response, I mean we can trigger the sending of OTP to their phone number if the login is successful, without the UI making another call, or the other option is to allow UI to, or make UI call another API, which is kind of send OTP API. In either case, I think we will still need a send OTP API, because imagine again this previous case that the OTP is not received by user somehow, and they need to trigger that again. So we can't ask them to send their email and password again, because they've already validated that, right? So we need to somehow just allow them to request for OTP again. So we will anyway need a send OTP API. Then once they send OTP, we anyway need a validate OTP API. So pretty much these are 4 APIs that we will limit to for now, right? And what we will do when we say API list and what we will build this API. So what does that really mean? So I want to talk about a concept of an API signature. So it is very similar to concept of a function signature. Anytime we say what's the signature of a particular function in any programming language, it typically means what's the name of the function, what are the input parameters of the function, and if it's a typed language, then what are the types of the input parameter set. Yeah, if there is any output parameters or return types, what's the value of those return types, right? And what are the types of that return type. So similarly for HTTP APIs, there's typically 6 or 7 parameters I think are super important and relevant. So one is first of all the URL, right? Like what's the API URL? That's the first one. Then the second is request method. Is it going to be get, put, post, delete, patch, whatever, right? That request method. Then we'll also need some headers to indicate possibly content type and request body and whatnot, right? Like type of request body and stuff like that. We will also need the actual request body, and this could contain some of the post data that we might want to send, right? Then from the response side, it's going to be status code on the response. Is it 200, 404, etc. Then there is response headers, and similar to request, response body, right? So these 3 are kind of dual of each other, and they all of these total make the signature of the API, right? So far everyone with me? Like if you have any questions, feel free to ask in between, right? That's okay. All right, so let's start designing. And for this, what I'll do is I'll switch back to the code, and we'll start with each of these APIs. So I'm going to stop the screen share and then share the screen again, where we will go through each of the APIs and we'll start talking about each of them, right? All right, so I'm assuming you're able to see my text editor.
Yes. Yes.
All right. Yeah. So we said this is the problem statement. We have API signature as these 6 or 7 parameters that we want to care about, right? And we said there are 4 APIs that we want to build. Like one is a sign up, other is login, and then there is send OTP and validate OTP, right? These 4 for now. So first, let's talk about URL itself. Right? So what's the URL going to be for sign up API, right? So typically for REST APIs, typically we have 2 options, right? I mean, if you think about it, in this case, I'm sort of elaborating 2 options. One option is our website is going to be silkystore.com, and we will typically, let's say, have a sign up page where people will enter their username and password. Now, if you think about this URL, this is the URL that people will see on the browser, right? Typically. Now, we want to have a URL which is different from this URL on the API, on the backend side. Yeah, because like a URL is a uniform resource locator, right? So it has to be uniform or unique, right? It has to be single point of a single URL. So typically for a web application, it is a good practice to make the front facing or the user facing URLs read URLs as good looking URLs. By good looking, I mean something like sign up or login, right? Imagine you go to any other popular website like Amazon, Google, whatever, and you go to their sign up page. So they are potentially also calling some API in the background, but the API path is different from the what you see on the UI. So the UI URLs are going to be user friendly, right? So this is the URL for a, not for the API, but for the UI application. Then what we can do is, typically there are, as I said, two mechanism of doing this. One is you can have silkystore.com or .in, whatever, and add a path prefix that every API will have a /API and then whatever the API that we want to build, right? That is path based. The other is sort of CNAME or DNS based, where you can create a separate subdomain or CNAME alias for api.silkystore.com, and then inside that you can have login and sign up and whatnot, right? So what will happen is JavaScript typically, or in case of Android or iOS, whatever the native app the code is written in, that code will make a call to this URL or this URL, right? Again, another thing that that I'm already talking about here is we are missing. There are other things that we can potentially and we should potentially do is a versioning of the APIs. Now, what do we mean by versioning? Imagine you built all of this website, you built all of this APIs, and you are live, and time passes, and there comes a time where some requirements change, right? And you want to modify some request parameters, or you want to start accepting some more information from the user as part of sign up or as part of login, etc. You are going to have to change the code. So in that case, you are going to have to ensure that the APIs that you developed are backward compatible, right? Or what will happen is you have to coordinate and change all the clients together, right? If you have a backward incompatible API. So this is where typically a concept of versioning comes into picture. It's kind of similar to how we deploy new software. This is like we want to deploy a new part of the code, but we also want to ensure the previous code still works, right? So we give some sort of versioning to the APIs. Again, there are typically two ways. One is the path-based versioning, or other is a header-based versioning. A path-based would mean instead of just saying API, we will add some version 1 or version 2, something like that, right? And via headers, it could be, the path could be this same, but as part of a request header, we could pass a particular header called API version, and then the value of that header will be v1 or 1 or 2 or 3, right? That is, so from the signature point of view, you can pass, you can tell the server which API you want to connect to and talk to, either by using the path or by using the headers, right? So anytime you design APIs, keep the URL in mind, keep the versioning in mind, and then come up with a, typically pick any one of these two methods, either the path like this where you have API/v1, or it could be api.silkystore.com/v1 and then sign up, right? In my production experience, typically I've seen path used more often than the headers, because it makes things more apparent on the UI itself, on the it's easier to see one, and you can use you can use simple browsers to actually fire get APIs, and that is another reason, because I can just copy paste this URL and put in browser, and if it's a get API, I can start getting data, assuming there is no authentication, authorization, etc. Right? So that is what I've seen. Now the next thing that we want to talk about is, so let's say we have finalized that we'll use something like this. Right? There is a silkystore.com/API/v1/signup. That is what we are going to use. Now, what are the options for request method? Right? What request method can be used? So for sign up, typically we are going to submit the data. So anytime you have to submit the data, typically use post. There is a concept of idempotency as well. Idempotency simply means, it's a fancy word for saying, can I repeat the same thing without having to worry about a side effect, right? So in terms of pure HTTP spec, get, put, and delete are idempotent, are supposed to be idempotent. Again, this is a convention and not something that is written in the spec of HTTP as such, but it's more like convention to use get and put and delete as idempotent, meaning if you try to get something back from the server, then no matter how many times you call it, there is no side effect on the server. You can repeat this operation without any problem. Same for put, like if you, and that's why put is typically used for updating a resource and not for creating a resource. Right here in this case, we are creating a user. Right, typically this is the data that we'll send to the server, and then we are going to create a new user with some username, password, mobile number, etc. Right, so in this case we'll use post. The request headers will be typically content type, that what kind of content that we will send, and then this follows the request body. If we are going to use form data, XML, JSON, then accordingly we need to change the content type. And typically imagine you will have some sort of JSON body where you will have either email and password and phone. In real world, again, you will probably want to have some client side encryption or encoding where you will encrypt the password locally and then send the encrypted password via HTTPS. That's the ideal way. So before we talk about the response, let's also think about what is the logic for this on the server side will be, right? Like imagine we got this data on the server. How are we going to do it? What are we going to do with it, right? So first, typically we'll validate the request body, right? Whether the email address has @ or one dot, and whether it's valid or not. Phone number is what, like 8 characters or not, 9, 10 characters or not, and whatnot, right? Then if all of it is good, and the other validations that we spoke about earlier, which are duplicate username, duplicate email, stuff like that, if we skip those for now, we will insert the record in some database, right, in some table or in some document or whatever database we want to use. And if there are any errors, we'll handle those. That's all that the API will typically do. Here we're just accepting data as the user sends it, right, without a lot of other kind of validation. And in that case, then response code will be either 200 okay or 201 created, one of these, right? Now, in the response headers, there will be, is there anything that we want to send? So if we want to send any content type, like if we are sending any content back in the body, then we will probably want to use some content type as, okay, we are sending JSON back. In case of errors, we might want to send some error message or error text. So that goes inside some JSON response. If it's all is successful, then we may not want to send any body. So in that case, we can skip the response headers. And here in this case, we could ideally send an empty body, or we could send the user ID, right? This results in creation of a user entity. So we can get the user entity ID and send that back. Right. So far, so good. Right. So overall, what we spoke is that we are, this is a signup API. We talked about the 7 URLs signatures, API signatures, 7 parts of API signature: URL, request method, headers, body, response status code, response headers, and response body. Right. So at this point, if we build this API and we make a call and everything is good, we will end up with a user being inserted in the database. Right. So what comes after that? Typically login. Right. So similarly to our sign up, we can have something similar. Like instead of sign up, we'll have login. Rest of the URL signature can be similar. In case of request method, it will again be a post, because what are we sending? We are sending the username and password, right? So in case of body, it will be again something similar, JSON body. In real world, we'll probably encrypt or encode the password in some way. Accordingly, the headers will have to be, application JSON and whatnot, right? And again, if we get this information on the server, now this is where things become a bit more interesting, right? So we will validate the request body, yeah, for sure. We'll check that whatever the email and password combination that is specified here, can I find a user from database with exact same credentials or not, right? And if there are any errors or problems, then we'll return 401 and whatnot, right? And there is this other interesting thing that we will have to do, which you should do, is create a token and send some token back to the user. Right now, you wonder like what's this token? What is this for? Right. So we'll come back to that. But to say simply that HTTP is a stateless protocol. Right. So as far as the server is concerned, between two HTTP calls, server doesn't know whether they are done by the same client or not, or same browser or not. So there needs to be a way to pass the state that, hey, this is me. I authenticated just now with you, and I want to now get an OTP, or I want to validate an OTP, right? So for that, you need some sort of secure token exchange between client and server. And that is why we should use something like either JWT or some sort of token to send to the user after the successful login, so that they can send this data back to us, almost like in traditional way, you would call this something like a cookie or stateful application, right? So in case of stateless, this is how you can make it work, that you have to pass a token back to the server. And server also has to either store the token or be able to validate the token without having to store it in some way, right? Now, in case of response, there can be multiple options. One is everything is good, username password combination is good. So well, you said 200 okay with the token. Maybe the token can be as part of request body or even headers or whatever, right? There could be either client-side errors like validation of email, invalid credentials, or unauthorized, or there could be server-side errors like database itself is down or not able to log in the user, right? Something like that. Now, in case of response headers, either we send the content type if there's going to be any body, and in case of like what we could do is this time limited token, which is this token that we talked about. That is what we could send as part of either header or as part of the body, right? And we spoke about this briefly, but we'll come back to this on why this token is needed. Fundamentally, this is needed because HTTP is stateless, and we want clients to have the state and server to not have to manage the state from the clients, right? So in terms of response, either this will be empty body or I have put it as a question that do we want to send OTP as part of response body? The answer is like no, it's a rhetoric question. Like we don't want to send it. We should send the OTP to the user's mobile number, right? We don't want to send OTP as part of the response, right? So, and we spoke about this already earlier, that if should we send OTP when the use on the UI when the user triggers another action, or is it like going to be a side effect of successful login? Both are options that are available to us. Both are kind of okay. It also depends on the UI team and how they want the UI design and how it integrates well with backend. Right? So based on that, you can do. It might just be easier to keep these things separate so that there is no side effect, and that's also a possible good option. Right. So far we spoke about signup API, then we talked about login. Now sending the OTP, right? So let's say we said that look, even if we send the OTP as part of login, we may still need to have a separate API endpoint for sending OTP again in case the user does not get the first OTP, right? So what does that API look like? So it's going to be send OTP. You can name it as something like send OTP, or it could just be OTP here.
Yeah, sorry to disturb you, but why would we want to send the OTP in response body? Because that invalidates the whole point of sending it to some other device which is with the user.
Correct. Yeah. So this is just as a trick question. We don't want to do that. So the answer is no. We don't want to do it.
Okay.
Yeah. So this, because exactly as I said, if you send the OTP as part of response, then this doesn't become a two-factor authentication, right? It's just one factor, which is the API itself or the user's browser itself. Yeah. So in each of send OTP, it can be like OTP and a post or a send OTP. Again, the nomenclature or the as per the pure REST standard, this could be just OTP and a post, right? Or you could make it a bit more explicit and say that this is going to be send OTP, right? So let's say we keep it as send OTP for now. Again, this is going to be a post method because here we are requesting the server to perform some action, and this is not going to be an idempotent action. By idempotent, I mean anytime you request a OTP, there is going to be a most likely a new OTP generation, or a server will have to check. Again, this depends on how we implement the logic on the server. Like every time user asks the OTP, to create a new one and send it, or we have some time limit to the OTPs and we allow we send the same OTP that we've already created, which is probably, let's say, valid for 5 or 10 minutes, right? Based on that, things will change as an implementation on the server side will change. So we'll make this a post method. In the request headers, we should receive the tokens from that we got from the login API response. Now, can anyone tell me why this is needed?
Because we need to know who to send the OTP to.
Right, that is one. We need to know who to send the OTP to. Other way, I mean, one way is here. This is a question now. So then, does it mean we should send empty body, or should we send phone number as part of the API call? Right. So I'll talk about why, or I'll talk about the answer. Right. One is, yeah, we can always send the phone number in the OTP. If we do that, but we still need the token. The reason we need the token is because this is a public API. Again, by public, I mean anyone can make a call to this API. If we don't protect it via some token, the purpose of login is all moot, right? I could directly call this API as long as I know the user that I have in my database. I can just make a call to this API endpoint, and it will send the OTP to me, right? We don't want that. We want OTP to be sent only to the logged in users, right? So we want to be a second factor authentication. We don't want to be a either or kind of authentication. Either you log in via your username password or via OTP. We want it to be and operation, both. That's why only when the user is successfully logged in, that is the time we want them to be able to call this API. If you try to call this API without a good valid token that you receive from login, we should probably return 401 or some bad request. Right. So that's why this token is going to be important. That it's almost like you are trying to book a restaurant. You're trying to go into a restaurant and book a seat in the table. So you go to the waiter and you say your name, that look, I want to book a table for 4. Here is my name. And then that person tells you, okay, your token number is 14. Right. So you have that token number with you. You can always go back to that person and then ask for, okay, what's the status on token number 14? Do I have the table or not? Right. But if we don't have that, imagine you are going to be able to just say anybody's token number, like what's the status on token number 10, or can I have that table? The restaurant owner is going to ask you, are you the same person or not? If you're not, then I can't give you someone else's table. Right. So similarly, I can't just send you OTP without you having to be logged in. Right. So that's why this token is going to be important. So then the logic on the server side then has to accommodate this, right? So what does that mean? So one is, yes, we validate the token, right? If the token is not valid, then we tell the user, bye-bye, sorry, you have to get a valid token first and come back to me once you have a token. That means we have to ask them to log in again, right? Then if we have a token, now here are like two or three multiple ways, right? One is somehow we could also map, we could potentially figure out the phone number from the token. That is an option that we could do, right? Because if the tokens are stored in a particular way in database, or if the token itself has some information about the user, something like JWT, then we could do something like this, that we can figure out the phone number from the token, assuming it is valid. And then we don't need to ask the users to send the phone number, right? And probably that could be a better way, because imagine if we allow user to send phone number, then there is one more validation that we will have to implement, is that I am a valid logged in user, but I can't request OTP for someone else's phone number, right? So that check we anyway have to be implemented on the server, that whatever the token is and whatever the phone number is from the request body, they have to belong to the same user. Otherwise, I can't log in and ask OTP to be delivered for some other different phone number, right? So in that case, instead of adding extra validation and asking user to pass phone number, we might as well just rely on token, assuming we have that information in the token. If we don't, then yeah, we will have to implement that. Yeah, someone has a question.
Yeah, I was also thinking that it could be better in user experience point of view as well, right? Because you can enter either username, email, or phone number, and you don't have to. I mean, like if you're asking the phone number separately, then someone might have to send the email and log password first, and then send the phone number.
Correct. So the email and password is sent as part of sign up. As part of login.
Yeah, so it's an extra thing that the user has to do, right?
Correct. So user has to either type, or we have to send this data back to the user in some way, so that they don't have to enter the phone number and whatnot, right? Yeah. So in that case, it makes sense too. That's why if we can do it via the token, and it is possible to do it via token, then we should, there is no need to send a body. There's no need to send a phone number, right? Because if we send the phone number, then either the user has to enter it, or we have to send this back in some way to the client side, right? So if we understand this part, then the response is pretty simple. Like if everything is good, if the token is valid, everything is good, then yeah, we try our best to send the OTP. We'll typically, let's say, use some third-party library to send an OTP, right? Then if it's not valid, then we get invalid token, unauthorized, something like that. And there could be other 5xx error scenarios, which is third-party SMS vendor down, DB down, and whatever, right? Any other like issues on the server side itself. In the response headers, then yeah, I can't think of anything that is mandatory, because again, you don't send anything as part of this response. You actually send the OTP asynchronously almost, right? So there is nothing that needs to be sent in the headers or body. Most likely you can still, if you want to send some data that you think is relevant, you can do that, but none is also okay, right? So again, revising, we have sign up, user has sent email, password, phone, we saved them onto database, then we send them a login form, they entered their username and password again, then we send the token back to the JavaScript or front end or React or Angular or Android or iOS, whatever the app type, we send that token to that app. The app is managing to save the token in either local storage or the application cache or whatever it has, and then it is going to make a call to send OTP. We send the OTP back to the user on their phone number, assuming obviously token is correct and whatnot. Now it comes down to, we then, after this API is successful, we'll typically redirect user to a different screen where they can enter the OTP, right? So there is going to be, then we need to write an API for validating the OTP on the server side, right? So for example, we name it as something like, let's say, validate-otp. Again, we can, now here is a question, like what kind of method do we use? Because we are again, because we are submitting the data, it may be like get, it may be a post, right? Another question that I have is, if do you think a get should be used for something like this, or it should always be post?
Do we need a body to be sent?
Yes, the body will be the OTP that the user enters. So there is going to be a body. Now we have a one way to do it is via query params. That's why I've just, as an option I've written, like you can always pass question mark OTP equal to something like this, right? But if you want to do something like that, then would, what are the pros and cons, right? If we do it this way, then we are, because URLs are like they are visible in browser and they could be cached and whatnot, or they go, the URL part is not encrypted in HTTP. One can easily see the actual OTPs that the users are submitting. So this is clearly like kind of out of question from purely from a security point of view, right? So then, and again, because we are sending some data, then it actually makes sense to send it via post kind of call, right? So that's why one of the reasons why we should not ideally use get here, because then we will be forced to send value via some query params, right? And again, we will also still need the token here as well, right? Because again, same stuff, right? We don't want people to just call validate OTP endpoint without being logged in first. So the same logic that is applicable for send OTP applies here. In case of request body, you could use something like this, where you send the OTP. And again, on the logic on the server side is going to be very similar, right? You will validate the token. If it's not valid, you will return back to the user that time itself saying sorry, bye bye, thank you so much, or whatever, right, with the appropriate error. If things are valid, then you're going to check the token and OTP combination are correct. Again, you need to figure out the phone number from this token, right? So you need to know, okay, this OTP is for which user, and that you can get that information from the token, right? And there you can check on the server side, is this OTP valid? First of all, has the time limit passed, if there is a time limit, right? And whatnot. So all of that logic will be done on the server side. You will first extract from the token the username, user ID, some info like that. Then you will go to the database and get the user information. You'll probably will be storing this OTP somewhere. So you will have to, per user, right? And with some TTL, time to live, etc. So you will have to check what's the current time. Is this OTP that user submitted is valid or not? And is it the same, belongs to the same user and whatnot? Once all of the validations pass, then you say, okay, all good. You are now authorized, right? So in terms of then response, again, it's going to be similar, like 200 okay, 4xx and 5xx. Yeah. Response headers and response body can be empty or whatever. Now, here is another thing that I want to ask. Imagine if all of this is done. What's the whole purpose of all of this, right? We are going to allow user to make a call to the e-commerce store, right? We will have product catalog. We will have a bunch of other URLs, which will give you information about our products, categories. You can order stuff, you can add to cart, etc., etc. Right? Now, all of those are going to be APIs as well. They will also have some auth and authentic validation, because, right, remember, we only want people to call and browse the products and whatnot only after they're successfully logged in and verified using two-factor authentication. So what we will also have to do somehow is somewhere we have to store this state that whether the user is only logged in and not authenticated via second factor, or they have logged in and authenticated via second factor as well. Because only when both the conditions are done, that is the time we allow them to be able to call our other APIs, right? So again, there are multiple ways. One is you can include some more information in the token, and you can maybe return that token from here. So here I've written response body headers as nothing, but you could do that. You could send the updated token to the user to be used, right? And in all the other APIs, we will check that token will contain information whether the second factor authentication is complete or not. If it's not complete, then they're not going to be able to, we are not going to be allowing them to call those APIs. But only if the second factor authentication is complete, we allow them to call those APIs. So that's one way. There could be, I guess, other way where you issue a new token at this point, then you'll have to manage two separate sets of token and figure out, okay, whenever you query in the next API, you will have to query this token first. If it's not found, then maybe you query the other, or you don't query the other and whatnot, right? So there is again some bit of complexity there on how we want the errors to be shown to the users and whatnot. Like, for example, if you want to show to the user that yes, you are logged in, but you haven't authenticated the second factor, please do that first. Then you are going to have to do a lot of logic on the server side for that, right? So one option is in the JWT, or if you use JWT or something like that, you could add an extra parameter indicating whether the second factor is complete or not, and by default its value will be no. So if it's complete, then only then you allow users to make the next API calls. Does that make sense so far?
Yes.
All right, so some challenges, we already talked about this, right? Token before and after OTP validation. In this case, we said it is same. So we saw the problem, what problem it can cause, that you want it to be either different, or you want that information to be included, whether the user is authenticated by a second factor or not, right? So this we talked about already. Again, this is another problem where we said we will not care about this, but just from the sake of completeness, we allow user to request OTP multiple times. Typically, the way to implement this is add some timer on the UI or even backend side. By backend side, I mean you on the UI you add some timer that you can allow user to click resend OTP only after 30 seconds or 1 minute, right? Or even if someone calls the UI via postman or curl call or whatever, on the server side you return them bad request, or you have a rate limiting on the server side, right? So remember, any validation done only on UI is as good as no validation at all, right? So UI cannot be a source of truth for validation. The server has to anyway validate the information. So if the UI is to ensure that we make it easier for users to use the system, and the backend validation is more from preventing any attacks or any issues, right? Again, there is another thing, where do we store the OTPs and tokens and whatnot? This is again a separate session or things that we talk about. It could be stored in something like a relational database or Redis. Those are typically two options. The reason to not store it in server memory is that, again, if we do it in the server memory, our application will become stateful on the server side, right? That means if you want to launch multiple VMs, multiple servers, then we'll have a problem of sticky sessions and whatnot, right? You might have heard about that term. So we will end up having to implement something like a sticky session, and it has its own issues. So the whole point of designing REST API is to make them stateless. So that's why we push the state. If we have to store these tokens and OTPs, we push it to some stateful service like database, right? Either to be relational or Redis or whatever, like fast caching database, right? And then now, if we do all of this, then yes, then this API can then be used by both web and mobile, because mobile, you can manage and store tokens in the application cache, for example, and on web you can store the tokens either on like local storage or like via some other means, right? And then pass that token back to the next API whenever you call it, right? Or it can be in the application's memory on the browser side, something like that. All right, yeah. So that is what I want to cover. What I wanted to cover about API design. Hopefully, you get an idea about what it takes to build APIs. Typically, as a summary, you should worry about these 7 parameters, figure out URL, figure out request parameters like method, body, and headers. And similarly for response, figure out what's the status code, what are the headers, and what's the body, right? And for every API, figure out, this is another important point, is what is the logic on the server side? Like how will you implement it? What kind of validations do you want? And how will one API relate to other API, right? And always think from a negative or attacker point of view. Like if you make an API public, what are the implications of that? How and if can it be abused by someone, and how will you prevent yourself against that? What kind of rate limiting will you implement? How will you make it observable? Right? That's the part that we haven't talked about here, but these are a few things that one has to worry about. Yeah, any questions on? So I can always recommend like a good book on REST API design. There is a book called, like, I'm sure you'll find a bunch of books, but a book on REST API design is something that you should refer. I would also suggest reading Roy Fielding's dissertation paper on REST. Like that is where he introduced the concept of REST, and he added a bunch of other conventions and terminologies that he introduced. So go through that. And the last thing that I would suggest is, more than anything, is explore some of the public APIs, right? You will find there are APIs like GitHub's, then Stripe, and even Razorpay, and what have you, right? Like there's everything these days is based on APIs. So explore some of the public APIs of these systems, and especially fintech, if you can, it will be even more interesting, because they have to have a huge focus on security and privacy and whatnot, right? So explore the APIs, see how the URL structure is, what kind of request methods, how the token mechanism works and whatnot, right? That will teach you a lot about overall API design. Yeah, any questions, any comments? All right. Yeah, then that's it from my side. Thanks a lot.